Okay, hi, welcome to 1dv609 at Linnaeus University. We're going to have a lecture on system testing, and this first part of it is test generation from requirements and code. So let's first see if you can hear me. So please tell me in the YouTube comments if you can hear me so that we have proper communication. Okay. Don't see that anyone writes. Okay, so I can hear myself. Great. So you remember this one. This is the requirements pyramid. Essentially, you have seen it before. I've shown it before. In the top of the pyramid, there are the needs and goals of the users or the customers, or the ones that have the stakeholders of this application, and they are fuzzy because they are not clear, and they may be a bit different between different people and stuff like that. We interpret those needs and we perhaps create a number of features. For instance, a feature in a system could be that this system is having an authentication system that only allows some people into the system. We could have other features like, okay, this is a web shop, so authenticated users can buy stuff here in the web shop. Or we could have more features than that. So we could have an order system where people have, or staff in the web store can handle the orders submitted by the customers of the web shop. And we can have many different features, right? The features themselves can be specified in a specification as requirements. So requirements, can be expressed as use cases, for instance, or they can be expressed as lists of issues, or features themselves. So in this picture, I see the feature as something high level, and then we get more specified the lower we get. So a use case is a more specified feature, and the use case does contain paths within it. So we can do different things. If the user does this, the system will respond in this way. Essentially, a use case is a story of interaction between a system and a user of that system. Of course, the specification can contain other kinds of requirements, like non-functional requirements where, okay, the system should be responsive, or the system should be secure, or the system should comply to different laws and stuff like that. And all of these should end up as test cases so that we get information about the status of the implemented system, and we can understand the implemented system. The use cases themselves can result in different scenarios. So a scenario is a path through a use case. So for instance, one path through the authentication use case could be that I input the correct authentication credentials, and then I get logged into the system, right? Or another path through the same authentication use case could be that I enter the wrong credentials and I don't get access. Or perhaps a third scenario could be that I first enter the wrong credentials, get rejected, and then get an error message, and then enter the correct ones and get access. So So that is scenarios, right? So paths through a use case. Finally, the test cases that are connected to these scenarios are a scenario plus test data plus specifics of the system. So test data is actual usernames, actual passwords, actual user credentials. Specific username is so you take a scenario where we should enter, for instance, the correct user credentials, and then you decide what is the correct user credentials. You also need knowledge of the implemented system in order to create a test case, because you're going to be specific. You're going to tell where to click and what to input in what field. So the scenario itself does not need to be that specific. It is just a path for a use case. A use case normally is written in a way that is non-specific, that it does not specify how the software looks, for instance. So I would say in a use case, I would say things like user supplies user credentials. I'm actually not really talking about what kind of credentials this is. The user credentials could be, a username and a password, but it could also be an image of my face, or access to my camera, or something like that, or things like that. So a use case itself does not need to be that specified. Usually we want to avoid that use cases or requirements are super specified to allow developers to think for themselves, to allow developers to choose good solutions. And if we are super specified and we get it wrong, we need to change requirements a lot. So by being a bit more fuzzy when it comes to requirements, we allow some changes without rewriting these. When it comes to scenarios, those are actually just paths through the use cases, so those are the same. But the test cases themselves need to be very specified, and they are specific to a specific system. So in a test case, you would say that you would need to put this picture in front of the camera, and that should allow login. Or you need to provide this specific password and password and username in these specific boxes on the web page. Yes. So here we have a use case. So you can see that the user wants to get access to a restricted access. User requests access, system asks for credential, user gives credential, system verifies credential and presents restricted access. And then we had this alternative scenario, user gives invalid credentials, system presents that the credentials are invalid. This does not specify if this is a web application, a console application, or something. Doesn't specify if it's on iPhone or anything like that. It's very high level. Okay. So if we want to create test cases from a use case, we take different scenarios in the use case, and the scenarios are actually paths through the use case. So if we draw the different points in the use case like this, so here perhaps in the starting point, usually you want to have shows where you're starting, and you want to be more specific on what these represent. But here is that the user wants access, perhaps, and then the system presents that, let's see. So user wants to get access to the restricted system, user requests access, and system asks for credential. User gives credentials. So I think in my thought, at least, I've started the use case here, user gives credentials. So here user gives credentials because everything above that is the same always, right? So if we don't get, let's see, actually maybe this does not represent this one. If I get the invalid, no, I cannot save this. This is not, it's not a representative of that use case, I realize now. So here could be a scenario where you get back to a previous point in the use case, and these are endpoints where you don't reach anything. The interesting thing here is that when I'm looking at code, we have previously talked about code coverage. It's the exact same thought here with these use cases. So we want to have coverage over these different paths, these different transitions over them. So we want to find all scenarios. We want to find all the paths covered here. So we want to have one test case that represents this one and goes down here, another test case that goes down here, and another test case or another test case that goes down here and down here, another test case that goes down here and up here, and perhaps it goes down here, or down here, up here, and all the way down here. So you can apply the same kind of idea of path coverage on use cases. So here we have the example that I was looking for. So we have the same main scenario. So one is that the user wants to authenticate. 2 is system asks for username, password, and if the system should save the user credentials or not. So this now is probably more specified towards a specific system where you can save credentials. 3 is user provides username and password. You can see down here. And then 4 is system authenticates the user and presents that authentication succeeded. So the main success scenario is just a path down here. So in order to cover that main success scenario, we just need one test case. And usually, if you want to make testing simple for someone, and you just want to show that we have implemented this feature, maybe we just show them this main success scenario thing, right? The other scenarios, the alternative scenarios, we have 3A here. User wants the system to keep credential for easier login. So it goes from point 2, where the system asks for username and password, and if the system should save the user credentials. So we get to 3A. A system authenticates the user and presents that authentication succeeded and that the user credentials was saved. So that can happen in 3A. But in 4A, we have user could not be authenticated. And then system presents an error message and then go back to step 2. And you can see that from both 3 and 3A, we have paths to 4A. So for this simple use case, we can still create a lot of different test cases. So I would like to have the main success scenario, of course. I would like to have one where we're following the main success scenario, where we are not saving the user credentials, so but we are supplying the wrong user credentials. So we're going to get down in 4A, because I want to make sure that you can never log in with the wrong credentials. And then I will go up to 2, and maybe I would stop the test case if possible here. Or maybe I can create longer test cases where we are, creating more paths through this. So 1, 2, 3, 4A, 2, 3, 4 perhaps was you first don't get logged in and then you get logged in, but with correct credentials. And then I would make sure that I follow the other paths here. So 1, 2, 3A, 4 perhaps, and then 1, 2, 3A, 4A, 2, 3, 4, or something like that, if that makes sense. And the more scenarios I create here, the more certain am I that I'm actually have implemented a more reliable system. I have seen many times bugs where people, for instance, can go a path and then get logged in for some weird reasons because of the code. So once I gave this as an assignment for students to produce authentication systems like this, exactly like this. And I've seen all the different types of bugs you can imagine. So just for instance, where one gives a faulty password, but the password is similar to the actual password. For instance, it's having large caps instead of small caps or something like that. But and for some string comparison libraries may compare strings in ways where large and small caps doesn't matter. So it's like, you know, Windows file system. It doesn't matter if you have large or small caps, but in Linux, it matters. So I've actually seen these bugs. So I think it's a good idea to have several paths and not just create a single path coverage. Yeah, I want to talk about, I hope that it's also in a future slide, but I want to talk about when we talked about code and code coverage, we also talked about loop coverage. So since there are loops here in this use case, maybe we want to make sure that we go through these loops. If you remember, loop coverage was going through a loop 0 times, 1 time, and many times. So I would do the same here, where I not go through a loop and then go through it once and maybe go through it many times. Yeah. So when we are doing this, we want to make sure that we verify the implementation, that this implementation is what we specified. Did we get all the functionality that we wanted? So I think that is one reason for doing this. So we want to get feedback. Are we done with the implementation here? Should we continue? Do we have paths that we have not yet implemented in our scenarios? Yeah, and then the other reason for doing this is that we want to manage change. So if things changed, a requirement changed or something like that, we want to be able to test again. And in order to do these things, we need test traceability. We need to be able to track which test cover which requirement. And you have seen this one before, so I think that this kind of matrix is really good at that. And if you think now that you're going to do this in assignment 2, and you're going to get systems, open source systems, where the requirements are maybe not that specified. Maybe the open source system that you're looking at has requirements, and then you can just, okay, if they have names for these requirements, like use cases and stuff like that, of course you can put them down. But if there are no use cases and stuff like that, you need to think of the system, divide it into different use cases, or not really use cases, but divide it in different features at least, and then track features towards tests. So the test traceability matrix can help you in that. There are other kinds of requirements also. I spoke about the non-functional requirements. So functional requirements are like use cases where someone gets a need from the system. But non-functional requirements are requirements that are spanning all implementation, or some parts of the implementation at least. And non-functional requirements can be like, okay, this system needs to be compatible with another system. It needs to comply to different laws. It needs to have this and this performance. Like if we're creating a computer game, it needs to, run with a specific frame rate or something like that. This system should be able to handle this and this many clients at the same time. It should be scalable if the number of clients increase and stuff like that. It should be able to run in different countries with different languages and stuff like that. And it should be secure. It should be usable. It should follow the accessibility guidelines, etc., etc., etc. So these kinds of requirements are spanning all the other requirements. So for testing the non-functional requirements, you need to do very different things. And I think that we're gonna not go into many of these, but I think this is actually something that you should look into in these open source projects in assignment 2 also, where you can think about what are the non-functional requirements, what are for instance, the laws that apply here, or is this following a WCAG or something like that, accessibility testing. And then there are always an infinite amount of testing that can be done So we need to be able to set realistic goals on this, so that we, because here we really are opening up the possibilities of testing. So these non-functional testing, they require specific tools, for instance, and specific ways of doing things. So if we're talking about compatibility testing, so I want to make sure that my system is compatible with another system. For instance, that my program or my web application can run in Chrome, but it can also run in Firefox. This means that I need to test it in both, right? So I need to run it on every system that I'm going to be compatible to. So I've done my fair share of compatibility testing on Windows, for instance, the different Windows versions. So when we created games, we wanted them to run on different Windows versions. I've created a number of applications that needed to run on, for instance, Windows and Linux and Mac. And stuff like that. So that requires access to those systems, and that you actually have the hardware and the software needed to run these. For mobile phones, for smartphones, I think this is probably a nightmare, where you have different sizes of screen, you have different hardware, you want to set the minimum hardware, you want to make sure that we every time you release a new version, you are not introducing a compatibility bug that is, forcing you to or that excludes a specific platform or something like that. So I think when it comes to non-functional requirements, we often get explosions of testing. So and if possible, we try to automate these and run good tools for these things. When it comes to compliance, this may be that we're going to be compliant to laws and things like that. That means that we need knowledge about these laws, and they can differ in different countries. Yeah, and that means that we maybe need access to experts in law in these countries in order to do this. Performance testing and load testing and scalability testing might be a bit related, where we try and see the response time of our system under different conditions. So how fast is it without any load? How fast is it if it's normal load? How does it handle if we get abnormal load? And things like that. Those also require specific tools in order to do that. I hope that we have a slide on that later. Localization testing is interesting also. I've done a little bit of this. Localization is to be able to change language in the program. And this was one of the interesting things for me, because one of the games that we released was released on many different markets. So it was, not only in English and Swedish, it was also in Spanish, in German, Japanese, I think. And I don't know Japanese. Konnichiwa. I don't know more than that, probably. So I could not read the text and say that this is the correct text in the correct position. So in order to test that, we needed Japanese testers in order to look at that. And also introduced another thing that I didn't think of, and that was that the size of text or the length of text is different in different languages. So I think it was in German that the strings become longer. So if we had said a size of a button in our game, or a field with text in our game, suddenly the text could be 1.5 times longer. So we need to rescale buttons and rethink or rephrase things. Of course, that I could do, because I could still click my way through the game and look at the different screens and say that, oh, this string is too long. We need to increase the size of that button or something like that. Yes, so for some of these, for some testing, we actually need experts in other fields that can complement us. Again, this is a case where our differences becomes a strength within the development team. So if we are, from different countries or know different languages, suddenly this is an awesome strength of the team. Security testing, this can imply a lot of different things. It could be as simple as, really have a strong test suite when it comes to everything with authentication, so that we cannot be authorized into the system unless we have the correct password or the user credentials. But this could also mean that we need to scan our Git history and our code on our Git server to make sure that we have never uploaded by mistake any keys or something into that we not hard-coded any password into any file or something like that. This is especially true for open source projects. And, people are scanning Git repositories for passwords and for keys and all of these things. So we can also use these kinds of tools in order to scan our own repository. This could also mean that we are hiring experts again. So a lot of companies hire teams of, the white hat hackers in order to, see if you can find weaknesses in our system so we can improve our system. So in many different situations for non-functional requirements, we need other people who are experts. Security testing can also be that we are looking at the different, for instance, database commands that we're using in order to only use the ones that are more secure, so that we stop SQL injection things. It could also mean that let's look at the cookies that we have placed in our browser to make sure that those do not leak any secrets. It could mean that we need experts to scan our code so that we are always using secure functions, or that we salt our passwords. It could be all of these different things. And then usability testing could mean that we are making sure that we follow usability guidelines. We want to make sure that people are thinking that our system is usable, and those are usually checklists of things that we need to follow, like don't have one dialogue over another and stuff like that. Or I don't know super much about usability testing. And then we have accessibility testing. And this means that we need to make sure that our system is compatible with the accessibility tools that those who are having different kinds of disabilities can access our system. So this can mean that we need we should make sure that our color scheme, our CSS file is not placing red and green stuff on top of each other, because this and there are a lot of different tools for accessibility testing, where you can run on a web page and you can get a report back that, you need to update these and these and these are the things that you need to change. But since this is an explosion of tools and techniques, you need to be realistic about this. You cannot do everything. You cannot do everything to a optimal goal. You need to plan your testing, and you need to divide these among iterations and stuff like that in order to do that. So I placed a link to Wikipedia, and you can find all of these different types of testing, and then you need to check further in order to look into these tools. So this this course is not really about different tools. For instance, I'm not really teaching you a specific tool in this course. It's not a tool course. It's a more general than that. So the exact tools that you want to use for assignment 2, you decide on those. And I think do the best of that. This is an opportunity for you to learn a lot of cool tools that are new and that are used on the market, and you can become good at these tools. So one tool that is not new is Apache JMeter. Apache JMeter is a tool where you can, it's one of these old, probably implemented in Java, I think, where you can load test, or you can performance test your web page and your web server. And the interesting thing here is that if I have an authentication system, for instance, I can run Apache JMeter against my authentication system. I can specify that this is the way to go through these use case or these scenarios. And then I'm not just running one authentication. I can scale that up to 10, 100,000, 10,000 authentications that is happening simultaneously. So it will create a number of threads, and each thread will try to authenticate in the system, and you can specify how long it will take for all of these, and how fast they will be, and if it's going to be in a random interval and stuff like that. And I think this can also be interesting to do in assignment 2 in order to learn about this. So you can learn about how to test if a system can handle a large load. And I just want to give a little bit of warning, because if you are trying this on a live system that someone else has, you're probably going to get IP banned. So if you're trying out on someone else's servers, and you do a lot of connections to that server, and you run a lot of threads that each try different things, using JMeter, you can get IP banned, and this could be seen as illegal also. So I think this is for you who can run the system on your own server, and and then you do performance testing and load testing on your own server. Okay. There is probably on the course homepage a video on JMeter from one of previous year students, I think 2001 or something like that, that created an instruction video for that. So you can look into that. In that student's line of work, this tool was used a lot in order to performance test their applications. So learn from the expert. Okay, so we have now generated a lot of test cases, and I think that we should think about what do we want from these. So the first thing we've already talked about is coverage, like the path coverage or the loop coverage and stuff like that. So of course we want to make sure that every requirement is tested and that we have enough testing from that. And you can do that with just lining out the scenarios and making sure that all paths are covered, or making sure that you have loop coverage and stuff like that. We want to find bugs if there are bugs. This is our goal. Of course, we want to make sure that, okay, we have actually implemented this thing. We want to automate this in order to reduce painful regression testing. So we automate the checking of these test cases. That means that we want to have test data specified. This allows us to automate, and we want to use cool tools in order to automate this also. An ideal test suite is easy to change when requirements change. So we need traceability, right? We need to know if this requirement change, which tests are going to be changed also. And we want our test suite to be dry as possible. So if we automate and write a lot of code for testing, we want to make sure that that code is dry. So if you always copy an old test case in order to write a new one, you need to refactor that also. That is why we in TDD do the refactoring step in order to find the copied test cases, so that we can become more and more dry. We want to be able to quickly develop these tests, and it should not be hard to write tests. And I think one of the ways of becoming or quickly developing tests is to develop them first. Because if you develop them first, before the implementation, you are actually designing the implementation in a way that is testable. To retrofit an old system with tests is not quick. It contains a lot of different thoughts and how to, how am I gonna be able to run this specific part of the system? We want to be able to use these tests that we develop during development, not later. It's not for someone else. It's not for the testers that I'm creating these test cases. It's for me as a developer. I want this. We want to have it dry, and that means that we want to have a minimal test suite that still gives enough confidence. And since we cannot do perfect here, we are not going to overdo the testing either. I mean, the amount of testing should be weighted against the importance of the system. What is at stake? If this is a game, and maybe not as much testing as if we're sending up a rocket, right? Or if people are going to die, of course we're going to have exhaustive, well, not exhaustive, it's not possible, but we're going to have a lot of testing, right? We want to be super certain that we're not going to kill people. So enough confidence is dependent on the stakes. And we want to be able to have a test suite that allows us or enable us to release this system to the people, and so that makes the good that it's supposed to do. So acceptance testing or user acceptance testing is that the customer signs off this system and says that this was good work. We can run this system. Yeah. Okay. So we cannot do everything, but we still need to do a good job testing. So in order to do that, we need to do some assumptions. And as I don't know if you've heard the proverb that assumptions is the mother of all fuck-ups. Have you heard it? It is. Also, that we often assume stuff, and therefore we make mistakes because our assumptions were wrong. So we want the assumptions that we make to be as informed as possible, to be based on reality. So one assumption could be that, okay, we have changed this part of the system, so we are going to regress and retest the tests of those parts of the system, but we're not going to look at the other parts of the system. So that is an assumption. I mean, but code can be super connected, right? So even if we just change one part of the system, other parts of the system can also have changed if we have a dependency, or if we change data in some database and that part of the system also was connected to that data. So it's an assumption. It might bite us. So one assumption that we're going to make has to do with black box testing. So you're going to learn a black box testing technique or a testing assumption. So you remember black box testing is to look at the system from outside, and we don't know anything about the internals, and we generate the tests from the specification. So we have this black box with the square root function, we input 9, and the square root should come out a 3, right? So one black box assumption technique is equivalence partitioning. And equivalence partitioning says that we only need to find the different partitions of input and partitions of output and then we create a test case in each partition. So for instance, we could have valid and invalid input, and then we could have one test case that is valid and one that is invalid. So let's see here, we have a function called add user, and we input an age. So this might be, who can watch a specific movie or something like that, or buy alcohol, or we have some age limit, right? And we divide the input into valid input, people of the correct age, and then invalid input, the people who are not in the correct age. It could be like valid input could be ages from 0 to 120 or something like that. And invalid input could be, negative numbers or 121, because we don't believe that we will ever get anyone who wants to watch this movie who is 121 years old. We have several assumptions here. 120 was my assumption on how old a human can be. I don't know. How old was the oldest human that we have knowledge of? Anyone know? I mean, in some context this can be super high. Yeah. 122. Oh my God! So I need to update the slide, right? So the assumption was wrong, right? 112 recently, I think. Okay, cool. But I mean, it's not far from, at least. Okay, so equivalence partitioning would say that, okay, we take one valid age and one invalid age, and then we try the system with these ages, and then that is it, sort of. So take this a bit more complex function that takes 3 inputs and returns the highest of them, right? So we have A, B, and C, and we're going to return the highest of these 3. All inputs must be positive numbers, bigger or equal to 0, and it throws exception on negative numbers. In this case, we can think or partition in many different ways. So the partitioning is sort of design of our tests. So let's think about, a simple valid input and invalid input again. So an invalid input would have a negative number, right, in one of these. And then we have valid input, which would be positive number in all 3. Yes?
When we test, for example, this function with the invalid input, do we make one test for each input?
Yeah.
A is negative or B is negative.
Yes, so I get the question, do we create one test case for the case where A is negative, B is negative, and C is negative? And you're actually on sort of the next way of thinking of equivalence partitioning. So another way of partitioning this would be to partitioning the invalid ones in 3 different parts. The first one would be that A is negative. And the second one would be that B is negative. And the third one would be that C is negative. So with that, in that case, we would need 3 test cases for the invalid things, right? But there are other combinations where A and B is negative, and A, B, and C is negative, and B and C is negative, and A and C is negative, but B is positive, right? So we can design the partitioning ourselves. So we design sort of the rules for this, and in each of these partitions, we can create many different test cases. I mean, if A should be negative, but B and C should be positive, we can have -1, 1, 1, or -2, 1, 1, or -3, 1, 1, or something like that, right? So there is almost an infinite amount of test cases in each of these partitions. But the idea here is that we create a partitioning, and then we select one test case in each partition. And there are other ways. I mean, the valid ones have the same thing. So A should be the highest one. So it could be 3, 2, 1. And B should be the highest one, is another partition. 1, 3, 2. And then C is the highest one, 1, 2, 3, right? So we can divide this into different partitions. So I get a question. Let's say if we have something like if A is less than 0, or B is less than 0, and C is less than 0, then you would still need to do this. Yeah. So the technique, the sort of technique here now, remember, is black box. So we're thinking from the outside. We're not really thinking from the inside. But of course, if we have knowledge of the source code, we should be able to use that knowledge in order to test our code better. But the knowledge of source code is always connected to that specific source code, and the source code can change. So my at least the thought that I have is that I want to protect myself as a developer and future developers and myself in the future from making mistakes by creating a test suite that is minimal but still, finds all the bugs that can happen. Yes. So for this simple max function, we can create a number of different equivalent partitions. So I want to go back to the definition of this one, because I usually tell or give questions on the exam on definitions, right? So it says that divide the input into equivalent. And equivalent means that all of the values, so to speak, all of the different ways of inputting in the input domain, in the equivalent partition should be equal, or they should be equivalent compared to how the system works. So all of these are valid. We don't differentiate them when it comes to valid ages. We don't differentiate between 0 and 120, so to speak. And this word, disjoint, means that no single input is in both sets. We cannot have 0 also in the invalid input and in the valid input. That is illegal for this to be an equivalence partitioning. And they are subset of the input domain. So we take the entire input domain, and that was all the possible inputs into a system, and then we divide that into different parts, and those are and those parts need to be disjoint. So equivalent disjoint subsets. So to get back to white box testing, I mean, code can look like this. There's a lot of different if statements. So if we have knowledge of the code, we really need to think about what happens here. So in the case of having all of these different if statements, we can still sort of divide the different or create this equivalent partitioning. So I think it's the idea here actually helps us a little bit. But if I'm in black box mode, I may forget about these sort of. So code matters, and if I have all of this if statement, I need to realize that I can go into this one, so that maybe needs to be a partition, and into the second one is maybe that is a partition, or third one maybe that is a partition, or the combination of 1, 2, 3 is a combination. So I don't think that this equivalence partitioning always helps me, because it's just from the outside, and sometimes it doesn't matter. If this division here is just one if statement that is, checking that we are in this span, maybe I only need 2 or need 1 test case for that one. Yeah. And sometimes I have no idea of the partition when I look at the code. I mean, so either maybe I should divide this into a string which contains a line break and one that doesn't contain a line break. So when it comes to code, I think that this sort of breaks down a little bit. So I would combine black box thinking with white box thinking in order to get my test cases. There are multiple partitions also, so you can have different axes of this. So let's think about a function called getLoan that decides if someone should get a loan or not. And customers of age 18 to 65 gets a loan if their salary is bigger than 25,000 pounds for some reason a year. And first, we should identify input domain. So the age is like that, maybe then 0 to 122. And then salaries are also from 0 and up to infinite, I guess, from and then we equivalence partition these into subsets so that we have age invalid ages up to 0, right? From negative something to 0, we have invalid ages. From 0 to 17, we have customers who won't get loans for that reason. And then from 18 to 65, we have the sort of the valid range of people who are gonna get loans. And then we have 66 and up to 122, which are the people who are, humans, but are not getting loans. And then we have the 122 above, which are invalid inputs and stuff like that. And then from the salary, we would have 0 to 25,000 and stuff like that. And then we create combinations of these. And so you would end up with something like this. Where I have salaries on the x-axis and age of the y-axis. And we can have different reasons for not getting a loan, sort of. So you would, for down here in E1, it's error, sort of, no, equivalence partition 1. Means that you are underaged and don't earn enough money to get a loan. And over here, you're underage, but you earn a lot of money, but we are not going to give you because you're underage. And here, you are old enough, but you earn, but poor. And over here, you're too old, but poor. And over here, you are too old, but you earn a lot. And E5 is where you're sort of valid. Of course, there is this case here with 122 and stuff like that. And maybe we just ignore these negative numbers because, for some other reason. So with this multiple partition, we would like to have at least one test case in each of these quadrants. And then on this one, hopefully you've heard also about boundary value analysis. So we developers tend to do mistakes on the boundaries of these partitions. That means that maybe I'm writing an if statement, and the if statement says 18 larger than 18, for instance, in order to get a loan, instead of larger or equal to 18. So that is a common mistake. We sort of use the wrong comparison operator. So it makes sense to create test cases on the boundaries of these partitions. And usually we try to have one on each side of these boundaries. So that would mean that the E1, where you're too young and too poor, the age you would put there would be 17, because you're too young and you're on the edge of getting it, right? And in E2, you would put the age 18 or put the age 65. So you're old enough, but I'm on the edge. And then we would put, when you are getting this loan, you try to put it on the edge also here. So you put the age 18 here, and a salary that is just enough, 25,000 exactly, just enough. And up here, you're gonna put one where you are 65 but still get a loan. Yeah. So if you can select test data, put it on the edges or on both sides of the edges, so that you are, that would create a stronger test suite. Or so they say. Now you need a break, and I need a break. And we're going to continue with system testing in 15 minutes, so 10:25. Okay, let's start again with the second half of this this lecture, system testing. And this has to do with, looking at a software and planning its testing. And this is highly relevant for assignment 2. Essentially what I want you to do in assignment 2, right? So let's start with the word test strategy. So as test strategy is to reach goals with, or strategies to reach goals with means. So first, we need to think about what are the testing goals. What do we want to achieve, really? And usually we want to have, to get to get knowledge from the software on its implementation, so that we know which requirements are implemented and which are not implemented. And then we want to, find bugs, build confidence in the software. And then we have the second part is the means. How can we reach these goals, what are the resources that we have? Those are the means, right? And the strategy is how to reach the goals with our means. So first, we need to put down our goals, and in order to put down our goals, we need to know what is at stake. So, and the ones who knows that is our stakeholders, those who are going to get their goals fulfilled by the system, right? So let's think about their testing goals. So for instance, for a web shop here, we have the web shop owners want the full process of shopping tested every day. This to make sure customers can fulfill purchases. They want to test the full shopping experience every day, because they want to make sure that they actually can sell stuff. So I don't know about you, but I have encountered several times web stores where I cannot buy stuff for different kinds of reasons. Once I put a lot of products in my shopping basket, and I think I reloaded the page or something like that, and the price became 0 for all my stuff, like 20 products and price 0, which was an interesting bug. Okay, so these stakeholders can also be you, and I assume you're going to be the developers then. So developers want to be able to, work with their code, refactor their code without destroying any existing functionality. So these are different kinds of goals from different stakeholders. And of course, there can be other stakeholders here. We can have the government, for instance, want to make sure that your application complies with the laws and regulations of that country. So there can be a lot of different goals. And then we have the means, is essentially a budget of time. So if we think about how much time do we have, maybe in my work as a teacher, I get hours for this course, right? So I have my means for doing this course is a number of hours, like 120 hours or 200 hours or something like that. But time is not only, amount of hours, it's also the time that I can work with you, so to speak. So when are the different lectures going to be? When are the deadlines going to be? Can this happen before this other thing? During this course, for instance, we have time problems with something called Christmas, which from an educational perspective is a problem, right? Christmas and New Year's is a problem because I do not put lectures on, Christmas Eve and stuff like that. So there is a budget with time and possible time and, me and stuff like that. And then we have people. And people are also resources within this budget. So it could be that we have ourselves, right? The developers. It could be that we have access to customers, specific testers, experts in different fields. So if we're going to do all of these non-functional testers, do we have access to these people? We need to book these people and get access to them. If we don't have access to an expert, we are not going to be able to run that kind of testing. Equipment, computers, specific hardware, rooms, I mean, even online stuff like cloud access. With equipment, I would keys to different systems, keys to different rooms. If I'm going to run my tests on both Windows and Mac and Linux, I need these machines or virtual machines or whatever, access to those things. Tools. I mean, these are test tools that I take up here, but it could be that we're going to perform testing using some tools, and they might be proprietary, or someone needs to buy them. We maybe need valid licenses for these and stuff like that. And there can be other things in this budget also. It could be actually be just money. It could be a budget of money. So depending on how much resources we have, we can do different things. But usually the budget is limited. And then if I have goals and a budget, I can make up a strategy. So how are we going to do this? And I've just written an example. Since the application is relatively stable and deployed, we want to test the shopping requirements use case 2 using fully automated tests on a deployed system. We want to ensure availability, monitor uptime, and integrations with payment and order subsystems. So in order to fulfill the web shop owner's goal, right? A strategy can also be that, okay, since we have limited budget, we're going to focus on something specific. So an example of a focus could be in this iteration, we focus on the ad system API since developers released a new version of that. We also run regression tests on the authentication system that was updated. So in this case, we focus our testing effort to the things that have changed or that we have new versions of. So we strategize and we say that, okay, this iteration we're going to do this, next iteration we're going to focus on this one, third iteration we're going to have another focus and things like that in order to not bust our budget. And often it is people and time that is the problem. We need to think about, okay, what should be tested? So we can focus on different requirements, for instance, or different qualities or the non-functional requirement. We can prioritize if there's any part of the system that is more important. Usually, I mean, of course, we're going to test the thing that we're developing right now. But maybe there are parts of the system that are so important, like security is often that important, like the authentication system. Maybe we need to run that every iteration, because if we not only run the test for the authentication system during development of it, but we also run it every iteration after that, we're going to be pretty sure that the authentication system is solid in the end. And we should think of what should be regressed. Okay, even if we have tested this part of the system, the shopping part, maybe we need to regress that. And maybe during the last iteration, we got some problems with a part that we focused on at that time, so we need to regress that part. We test that again. Maybe we just look at the code and see a diff on the code and which components have been updated, or microservices has been updated. So of course we're going to test on those. Yeah, we can, or in order to do this, we need traceability of test results. As much as we think of what are we going to test, we can also decide what not to test. What can we exclude this time? And maybe this gives us a better way of prioritizing. So clearly describe requirements and test suites that we're not going to test this iteration. So we're not going to test the authentication system with manual UI tests since it's not been changed and has been stable for a year. Makes sense to not test it anymore, right? However, we did run the automated test suite because we always do that, because it's cheap. Because regression testing of something automated that is also fast is cheap. So of course we're going to do that. So whenever I talk about prioritization here, a nice thing with automation, and if the tests are fast, is that we can run them cheaply, so we can always run them, right? So this is the testing pyramid. So how are we going to do our tests? And in the bottom here, you have unit tests. And the pyramid is wide at the bottom because we should have most of these. So if you're building a test strategy for a program, it should rely on unit tests of the small components mostly. This is what we have hundreds and thousands of tests. And then above that, we have component tests. Okay, classes or bigger components like the database component or whatever it is. And we have automated tests of this one, but fewer than the unit tests. And above that, integration tests. So, okay, we make sure that we have integrated between these two, the front end and the back end properly. And then above those, we have API tests. So like, let's test the different API functions in the backend that test the entire component of the backend. And then we have user interface tests. These are often the slowest to run because we are interacting with the user interface. We're still automated here. And I'm going to show you a couple of tools that you can use in order to automate at least web applications. And we have sort of fewest of these, and then we have manual testing above that, and that is these expensive. This costs resources for real. Here you need, people are actually going to do and click here and be bored about checking. So we're going to do fewest of that one. So that is the testing pyramid. So you build on a lot of these small things that are super fast, and the higher you get, the slower things get, and the more costly they are. So how are we going to do this? What kind of technology choices are we going to have? Of course, you're going to select different tools for automation, but you might also want to have some manual testing on top of that. Maybe you want to have some exploratory testing. I think this is a really good idea to have some exploratory testing. By now, you should have watched James Bach video on exploratory testing as one of the external resources, where he tells you about banging on the keyboard and stuff like that. Because I think that having someone, just doing validity testing and see how does this system work, can I break it, is a really good idea, and that someone puts some creativity down into this. Maybe you want to release a beta version of your system to some select part of the customers, or maybe you want to involve the customer or not, or maybe you just want to work with these automation tools. So this is one of the different automation tools for web applications. So this is called Selenium WebDriver, and you can write stuff like this. So I want to find a specific element on a web page called the color input, and then I want to click that button, and then we can write code for that. In the background here, this is Postman, where you can create test cases. So there are many different test tools, and I'm just going to show you a couple of ones. The first one, Postman, is good for backend testing or API development, right? So yeah. So in Postman, you can create or talk HTTPS. So you're going to send messages to your API, and you're going to check the responses that you get back from your API. You can log in, you can, and you can save these test cases and run them as test suite in Postman. Of course, this type of testing is high up in the pyramid, which means that you need a server up and running, and then you run Postman against that server. So it's going to be HTTP messages going back and forth. You don't really need to look into this. I think if in A2, if the application that you are testing has a backend, I think writing Postman tests to that backend would be a good idea to learn. And then we have different ways of browser automation. So I've taken up 3 different tools because they have been popular from my students. So we have Cypress, and this browser automation is to write unit tests, and they are essentially to be run inside a browser and run against your web application. So you're writing code that interacts with the web application. Like, okay, I'm going to click on this button, I'm going to do this thing, and it automates testing. So you can take your manual test cases and you can automate those, the interaction with your application. Selenium WebDriver was sort of the same, but it's just an alternative. It has, I guess it's the oldest of these. So you can interact with the different things. You can get the different items of the web page. For instance, you can, I click on these buttons and then I extract the title of this page and I can check or assert that the title is the correct one, right? And Puppeteer is also popular. So here, maybe this is more like a browser itself that you can run. So I think Puppeteer is not run in your browser, but it has an internal browser, if I understand it correctly. So we can go to this web page, we can set the viewport of this virtual browser like this. We can do different interactions, and then we can assert stuff, I assume, on that one. So there are different ways of automating these kinds of interactions. Okay, so now when we have decided how to do it, then we need to judge if it's okay or not, or what is going to happen if the results are not okay. So tests are producing feedback. First thing is how do we judge if a test result is okay or not? Then I think this is the oracle thing, right? So we need to have access to someone who can act as an oracle. That could be the product owner of the product that decides this is the way our product should be. This could be a group of people. And then we need to decide what happens if it's not okay. Who should work with this feedback? It's no use producing feedback if someone does not receive that feedback, right? And how much testing do we want, and what is good enough, so to speak? And good enough depends on stakeholder goals. So maybe we want to have developers want high code coverage. We say that unit test coverage should be above 85%. That is sort of the decision that we make. I myself really don't like these percentages and stuff like that. They become these kinds of rules that people tend to stop thinking for themselves, and then they are just complying by the rules. So the moment people start to measure me, I'm not going to think about quality myself. I'm just going to think about the measurements, so to speak. I'm not sure if you get what I mean, but many businesses and many schools and I think police and schools and healthcare, all in Sweden, all suffer from this. That we are measured in different ways, and we try to optimize the ways that we are the scores that we get, instead of optimizing for the most usefulness. for you as students, if you're optimizing for your grades only and not for learning the skills, and then we are sort of having the wrong focus, right? Just because we have these grades, it's easy to get, I need to optimize my grades. And of course, some people are going to maybe pay you or not pay you, depending on these also. So they become incentives. Okay, yeah. But we also need to understand what happens if we don't reach these goals. So maybe if I find out that we have very low coverage, if it's my job to find out, maybe just acknowledge the lead developer of this, that we have low coverage in this part, and then the lead developer does something. Maybe it's up to me. Maybe I'm not even allowed to merge my code unless I have a specific coverage. I think problem with automated measurements is that people are going to cheat even to fulfill such things. So I think that people should think that they should produce usefulness. Okay. The how also depends on what we intend to do in the next iteration. This has to do with focus. So the test plan, or the things that we work now with the different the different decisions that we made, is a plan. And a plan should guide the work effort. And in order for a plan to actually run, so to speak, and something should happen from the plan, we need someone who is responsible, who should write tests, who runs those tests, who has the vital information, who is going to use the result, and also a plan is just a plan. Then reality is going to happen, and it's always good to have plans, but most things that we plan don't go exactly as we intended. So we should still have this usefulness focus and not be just, it was not in the plan that I should do something, so I just sit and do nothing. In the plan, we should also include risks. So things might go wrong for different reasons, and we should be knowledgeable about those risks, and we should be knowledgeable about the different assumptions that we have made. So what can affect our testing process? And there can be a lot of different things that we need in order to do testing. So in order to do testing here, I need access to this system, or I need access to these people, or I need this part of the system needs to be implemented before I can test that part and other parts. And of course, the test environment itself needs to be available, and I need access to that in order to test it and stuff like that. So, and sometimes we actually need money in order to do this. So as part of the plan, there is also think about how can this go wrong and what can we do to mitigate those risks, which means to minimize the risks. Also, I got a question regarding assignment 2. Should the project be in PHP? No, you can choose any open source project in A2. Yes. And a plan is a plan which is communication. A plan should guide one or more individuals to work together. If I don't understand the plan, if I don't understand the usefulness of the plan, if I don't understand the strategy, if I don't understand the different tasks, if I don't see myself doing the things, then we have a problem. So clarity is super important, how to write this and how to be clear about it. And how to be clear when we are different. Depending who is talking to each other or who is communicating, we need to adopt our language depending who is communicating, right? So Information transfer happens, yeah, depends on who are communicating. So if I'm communicating to you as students, maybe I need a different kind of language. I need to understand a little bit about your situation in order to successfully communicate on what you're supposed to do. A part of how, I think, is if I have a result from testing, we also need to specify in what form should that be? How should that be presented? Since this is feedback, who should receive that feedback? And what should they do with the feedback? If it's just a report, who should look at that report? What kind of decisions should they make with that report? Usually, I don't like reports. I don't like documents where I don't have any idea why I'm writing this, or the reasons behind this, or the kind of decisions that is going to be made by this. So every year I write these reports that are going to be handled, and someone is like, and then they throw that information away. And I put hours in producing that information. So think about the usefulness of this. And results can be presented in many ways. I mean, it could be lists of tests. It could just be a number that 100% of the test ran successfully. And maybe that is all that is needed in order to say, to make a decision. Or if we have broken the system, 25% of the tests are running, we as developer need to fix this now. I mean, traceability to requirements is good if these requirements are changing. Yeah, I think this one is also an interesting thing of a plan. When is an activity due? Like, okay, how much time do we have? Who should do that, and how much time do we have? Yeah. When we are in small teams, I think you create these reports for your own sake. And if you don't need a long document, you don't need a long document. Maybe the only thing that you need is the output in the console from your tests. And from these good test tools, they produce this kind of reports for you. Yes. Okay. I think that was it for me today. Thank you for listening. And yes.